Now that we know what radicals are, let's take a look at instances where we have some exponent with a fraction in it being raised to another power, and looking at the different types of radicals. So we have mixed radicals and we have entire radicals. Okay, so we have to remember our exponent laws. So if we have some number 8, it's being raised to the power of 3 over 4, and then that is being raised to the power of 2 over 3. So anytime we have a power being raised to another power, what we do is we multiply those two numbers. So this is the same as 8 to the power of 3 over 4 times 2 over 3. Okay, so 3 times 2, right, these two right here, that's going to give us 6, so 8 to the power of 6, right, divided by 4 times 3, which is 12. 6 over 12 is just a half, so 8 to the power of a half. And in the last video, we talked about how anything raised to the power of a half is the square root of that number. And another way we can do it is we have our radical symbol here. We have our 8 as our base. Remember, the exponent that 8's being raised to is the top number, and the index is the bottom number. So we don't need to write this 2 here in the 1. It's just kind of assumed that it's there, so that's the same as the square root of 8. Okay, so anytime we have the radical and then the entire number inside, that's why it's called the entire radical, because the entire thing is inside the square root sign or the cube root sign or the fourth root sign, whatever it is. All of it's inside. A mixed radical is where we mix it up. We bring some of it on the outside and we leave some of it on the inside. So the stuff we bring on the outside is a coefficient, right? A number multiplying into the radical is what we can square root in this case. So we have to think of 8 in terms of its factors. So 8 is the same as 4 times 2, right? And the square root of 4 is just 2. So we can also write this as 2 times 2 times 2, right? This equals 8. Okay? So anytime we have a group of 2, right? 2 squared, in other words, and we square root it, we just get one of these 2's. So on the outside, we're going to have 2, and these 2 are gone. What we're left with on the inside is kind of the 2 that didn't fit into that group of 2. So 2 root 2 is going to be the mixed radical form. Okay, so this is the mixed radical. Mixed radicals have a coefficient on the outside, and then whatever's left over on the inside. Entire radicals, everything's on the inside. Okay, so 980. Okay, let's think about this in terms of its factors. So they already did part of it for us. They said the square root of 980. This is an entire radical. So right now we only need to focus on getting into its mixed radical form. So the square root of 980, I'm not going to write the 2 there because it's kind of assumed in math that there's no sign here for the index, it's just 2. So 980 is the same as 98 times 10. Okay, so I'm not quite sure what we're going to do with this, but I know for sure, because there's a 0 on the end, we can divide it by 10. 98 times 10 is 980. And I also know that we can split up 98 into 49 and 2. So 49 times 2 times 10. And I also know the square root, because I know my multiplication tables, the square root of 49 is 7, right? Because 7 times 7 is 49. So this is going to be 7 times 7 times 2 times 10. So see how we have a group of 2 7's here, and we're square rooting it? So when we get the square root of 49, we just get 7. So on the outside, we're going to have 7, and what we're left with inside is going to be 20. So 7 times the square root of 20, right? Because 2 times 10 is 20. We took out this 49, and we're done with that. So you might think that we're done, and this is in fact a mixed radical, but it's not fully simplified, because 20, remember, is the same as 4 times 5, and 4 is a perfect square factor of 20, right? So the square root of 4 is 2. So the 2 is going to join the 7 on the outside, so it's going to be 4 times 2 times the square root of 5. Or sorry, 7 times 2 times the square root of 5. So 7 times 2 is 14, so this is going to be equal to 14 times the square root of 5. Okay, so that's the fully simplified mixed radical version. Okay, so now we have 2 times 54 squared raised to the power of 1 over 6. So let's leave the 2 on the outside for now. Let's write this as a simplified exponent. So this is 54 to the power of 2 over 6, because we go squared, right? That 2 times 1 over 6, that's just 2 over 6. Okay, and this is the same as 2 times 54 to the power of 1 over 3, right? If we simplify that. So remember, if we have an exponent in a fraction form, right, it's going to be 2 times, this 3 acts as our index, so 2 times the cube root of 54 to the first power, or just 54. So let's split the 54 into some more factors. Whoops. So this is going to be 2 times the cube root of, let's write a bunch of factors in here. So 54, that's 2 times, what, 27, and then 27 can be broken up into 9 and 3, and then 3 can be broken up into 3 and 3. So 54 is the same as 2 times 3 times 3 times 3, right? 2 times 3 is 6, times 3 is 18, times 3 is 54. Okay, we're good. So the cube root of 54, anytime we have the cube root of something, we're looking for groups of 3 for factors that kind of make up the number. So I see right here we have 3 3's. If we're cube rooting it, right, our index is 3. 3 3's is the same as 3 to the third power. Remember, cube rooting, raising to the third power, this is the same as 3 to the 1, which is why when we have a group of 3 for a cube root, we only take out one of them. So this equals 2 times 3. So all these 3's are gone now, and now we have times the cube root of 2. And 2 times 3 is just 6, so this equals the 6 times the cube root of 2. Okay, and if we wanted to go backwards, if we wanted to start with our mixed radical, right? If we wanted to start with our mixed radical and go into the entire, we would have to bring the 6 back in, so it's entirely inside the radicand, and we'd have to cube 6. So 6 cubed is 6 times 6 times 6, which is 216. Okay, and yeah, so this would be the cube root of 2 times 216, and that would be our entire radical version, right? So if we were to bring this 2 back in, we'd get the same answer doing that. Okay, so estimate the following, the square root of 8. Okay, so one important thing we're going to have to know before we do these estimate examples is that the square root, okay, the square root of, let's do 2, okay, the square root of 2 is 1.414. So alterate 1.4. And the square root of 3 is also probably pretty useful to know. So the square root of 3 is 1.73. So let's go 1.7. Okay, so the square root of 8, right, that's going to be, well, we know the square root of 9 is 3. Okay, so we know the square root of 9 is 3. How can we think about this? So if we're taking the square root of 8, we know it's going to be a bit less than 3. So my guess is going to be 2.8 maybe. But the square root of 8, remember, that's the same as the square root of 4 times 2. And 4 is a perfect square, so if we square that, that's going to be 2 times the square root of 2, which is 2.8. Okay, so we can think about it this more analytically, or we can just say, well, I know the square root of 9 is 3. 8 is a little less than 9, so that means the square root of 8 must be a little less than 3, about 2.8, and that is approximately the answer. So that's how we'd estimate the first one. Okay, 68 to the power of 1 over 3. Well, this is the same as the cube root of 68. And I know that 4 times 4 times 4 is equal to 64. So our number is 68, but 4 cubed, okay, 4 cubed is 64. So I think this is going to be about 4.1, 4.2. Okay, I'm going to guess it's probably 4.1. Not 100%, but if I take my calculator, right, I go 68, I'm going to go to the power of 1/3. Yeah, it's 4.08. 4.08. So what we have to do is we compare the radicand, the number on the inside, to another perfect cube number that we know. So we know that 4 cubed is 64. So the cube root of 68 is probably going to be like just over 4. So in our estimate, we'll round to the 10th power, or to the nearest 10th, so 4.1 would be my guess. And the actual answer is 4.08. Okay, the cube root of 29 times the square root of 98. Okay, so the cube root of 29, let's think about it here. I know that the cube root of 27 is 3, right? Because 3 times 3 times 3 is 27. So the cube root of 27 is 3. So if we're taking the cube root of 29, I'm going to say that's just over 3, because 29 is just over 27. So the cube root of 29 must be around 3.1. So if we're to do it in our calculator, right, 29 to the power of 1 over 3, that's 3.07, which is about 3.1. So this is going to be, I'll write a kind of squiggly equal sign. It's approximately 3.1, and the square root, right, of 100, okay, so if we have 98, 100 is probably the closest perfect square. The square root of 100 equals 10. Okay, so the square root of 98 is going to be about, I'd say 9.9, because it's just under. So it's going to be 3.1 times 9.9, about. So we have a number that's just over 3 times a number that's just under 10. This is going to be probably about 3 times 10. Okay, and this is going to be about, I'd say 30. Okay, so it doesn't have to be exact. We don't have to do 3.1 times 9.9 exactly, but 3.1 is just over 3, 9.9 is just under 10, right? That's going to be about kind of the neutralized version, which is 3 times 10, which is going to be 30. So if I take the cube root of 29 and I multiply that by the square root of 98, that's 30.4. So the actual answer is 30.4. And without even using a calculator, right, with just knowing our perfect squares and comparing them to what's inside the radicand there, we were 0.4, right, of a unit off, which is really good. Okay, it's really good. Looking at the cube root of 29 times 98 square rooted, getting 0.4 off is awesome. Okay, it's awesome. It's really close. So that's a good method to use. Okay, the square root of 46 over the square root of 5. Okay, this is a bit of a tougher one. Okay, so one thing that I'm going to teach you in another video, probably the next one, is radical laws. So how to divide and multiply radicals. But right now, I'll give you kind of an inside scoop into what I'll be talking about. If we have a radical and we're dividing it by another radical with the same index, in this case, it's the square root, this is the same as the square root of 46 over 5. So we can kind of combine it into one radical. Okay, and 46 over 5, right, that's about 9, right, because 9 times 5 is 45. And 46 is just over 45. So we can imagine this as approximately the square root of 9. Okay, the square root of 9 is 3. So since 46 is just over 45, I'm going to guess this answer is going to be about 3.1. Because 46 over 5, I'll write the square root of 9 plus small number, right? Because 46 over 5, if I actually do it in my calculator, yeah, that's 9.2. So if we were to square root that, this is going to be about, I'd say 3.1. Okay, so the square root of 46 divided by the square root of 5, this is, the actual answer is 3.03. So in this case, it's a little harder to estimate, but on a test, this would be a reasonable guess. Okay, just over 3, because we know that the square root of just over 9 is going to be about just over 3. Okay, fully simplify the following. Okay, so we have to think of perfect square factors of 20. So 20, we can break that up into 2 and 10, right? Or we can break it up into 4 and 5. And 4 and 5 is good because we can split this 4 into 2 and 2. Okay, so 20 is the same as 2 times 2 times 5. Okay, so if we have the square root of 4 times 5, the square root of 4 is 2. So this equals 2 times the square root of 5, because the 5 is what's left over. So this is going to be 2 root 5 for our first term, plus, okay, the square root of 18, split this into its factors, 2 and 9. So this is the square root of 2 times 9. And the square root of 9 is 3, right? Because 9 is a perfect square factor. So it's going to be 3 times the square root of what's left, which is 2. Okay, and then we have minus the square root of 5. Can't do anything with that. It's already simplified. Now 72, this is the same as 9 times 8. 9 is a perfect square. And we can split the we can split the 8 into 2 and 4. Okay, so this equals plus, remember the square root of 9 is 3. So we can go plus 3 times the square root of 8. And remember, 8 can be split into 2 and 4. And the square root of 4 is 2. So the 2 and the 3 are going to multiply. It's going to be 6 root 2. Okay, it's going to be 6 root 2. So what we have now is we have 2 root 5 plus 3 root 2 minus root 5 plus 6 root 2. So we can only combine radicals if they're adding or subtracting if the index is the same, which they all are for this example, right? There's all an imaginary 2 for these. And if the radicand is the same. So notice that this is the square root of 5 for these two, and for these two it's the square root of 2. So we can combine the root 5s together. So if we have 2 root 5s, and we subtract 1 root 5, we're just going to have 1 left over. So this is just root 5. Now if we have 3 root 2s, and we add 6 root 2s, that's like 3 plus 6 times root 2, so we're going to have 9 root 2s, and this is our answer. Okay, that's our fully simplified version. Okay, arrange this list of numbers in order from least to greatest. Holy smokes, what's going on here? We have a square root, we have a cube root, we have a cube root of a fraction, we have the fifth root of a power to 100,000, then we have the fifth root of 100,000 of the power of something. What the heck's going on here? Okay, so what I would do is I would first get this mixed radical as an entire radical, because then we can compare the insides. Okay, so the 2 times the square root of 3, if we bring this 2 in, we have to square it. So this is the same as the square root of 3 times 2 squared. So 3 times 4, which is the square root of 12. So I'm just going to write the square root of 12 here. So we have the square root of 12, the cube root of 12. Okay, so comparing the first two, the square root of 12 and the cube root of 12, if we square root 12, that's going to be it's going to be more than the cube root of 12. Because with the cube root of 12, we're saying a number times a number times a number is 12. But with the square root of 12, we're saying a number times a number is 12. So whatever that number is, it's going to be higher for the square root of 12. So if our radicands are the same but the index is higher, the one with the higher index is going to be a lower overall value. Okay, so right now I know the cube root of 12 is going to be less than the square root of 12. Okay, and I also know, actually I'm not going to write the order first, but I'll write, we'll just kind of keep that in mind. It's hard to arrange it, but the cube root of 29 over 2, right, 29 over 2 is a decimal, is 14.5. Okay, so if we have the cube root of 12 and the cube root of 14.5, obviously the one with the higher radicand right? Because they're both cube roots, so we're only comparing the inside. The cube root of 14.5 is going to be more than the cube root of 12. Okay, so far, the smallest number we have is a cube root of 12. I would say the square root of 12, or 2 root 3, is the biggest, and the cube root of 29.2 is kind of in the middle. Now, 1 to the power of 100,000, or 1 to the power of anything, 1 to the power of infinity, arguably it's just 1. Okay, but infinity is kind of a bad example because it's kind of a weird number, but 1 to the power of -5, 1 to the power of 0.1, 1 to the power of, in this case, 100,000. All of these equal 1. And if we take the anythingth root of 1, right, so in this case the 5th root of 1, it's just going to be 1 still. So this is just 1. Okay, now if we look at this last one here, the 5th root of 100,000, right, 100,000, all right, 100,000, that just equals 10 times 10 times 10 times 10 times 10, because there's 5 zeros in 100,000. So if we take the 5th root of this, we're looking for groups of 5 within this number. And would you look at that? There's 5 tens exactly. So the 5th root of 100,000 is just 5. Okay. So the square root of 12, right, that's going to be less than 5 for sure. 1 is definitely going to be the smallest number. So least to greatest, we're going to write 1 first. And none of these numbers are going to be bigger than 5, right? Because we know that the square root of 12 is bigger than all of these. But we also know that 5 squared is 25. So the number inside here would have to be bigger than 25 in order for it to be bigger than 5 overall. So 5 is definitely the biggest, 1 is the smallest. And we also said the cube root of 12 was the smallest out of the first 3. Okay, and we also said the cube root of 29 over 2 was just a bit bigger than the cube root of 12. And the square root of 12 was bigger than those. So now let's get our calculator and actually compare them. Okay, so let's do 2 root 3 first. So 2 root 3, I'll write it actually just below them. That's going to be 3.5 approximately. Okay, the cube root of 12, so 12 I'll write to the power of 1 over 3, is 2.9. Okay, and the cube root of 29 over 2, okay, so 29 over 2 to the power of 1 over 3, that's going to be, hold on, that doesn't make sense. Oh, sorry, it's not 2.9, it's 2.89. That makes a bit more sense. Or sorry, 2.289, what am I saying? So I'll write 2.29 approximately, and then the cube root of 29 over 2 is 2.44. 2.44, and then like we said, we figured out this part here using our exponent laws. So this is going to be the 5th root of 1, which is 1, and then like we said, this is going to be 5, and I'll just put it in my calculator just to make sure. So if we have 100,000, raise it to the power of 1 over 5, that is going to be, I don't know why I wrote 5 here, it's actually 10. I have no idea why I said 5. Okay, because we're taking 10, we're multiplying it by itself 5 times. I got mixed up with the index here. So 10 to the power of 5 is 100,000. The 5th root of 10 to the power of 5 is just 10. Okay, just a bit of a mix up there, but we still get the same answer because 10 is ultimately the biggest number out of all of these. So if we compare this, the 1 was right here. Okay, the 3.5, that was the 2 root 3, so that was right here. Okay, 2.29, that was right here. 2.44, that was right here, and the 10 was right there. So we did, in fact, order it correctly, just kind of comparing the insides and using our exponent laws. Okay, so we did lots of examples there with simplifying radical expressions. We're going to work more with this using our radical laws, so how to multiply and divide them, add and subtract them, maybe throw a couple equations in there, right? Make it a little harder. So we're going to really nail down on these radical expressions and equations. So I'll see you soon.